Hello, pre-calculus students. Today is an asynchronous learning day. We're going to take time and look at review of domain, range, and asymptotes. The assignment for today is to take notes and then submit them to Schoology when you're done. This is the homework for the day. So what I'd like you to do is when we get to a problem like this, press pause, and I'd like you to answer the following questions and draw a quick sketch in your graph, in your notes, and then we'll go over the answers here when you hit unpause, and we'll do that. And we've got a couple of problems we're going to do together here. So go ahead and hit pause. Try this. Your goal is to sketch the graph in your notes and identify the domain and range. All right, domain. Well, domain is the possible x values of your graph. And the first thing I notice is we have some special things happening. As I look at x approaching -1 from the left, my function is going towards positive infinity. As we approach -1 from the right, we're approaching negative infinity. And that is an indication that there's a vertical asymptote right there at x equals -1. We also have the same behavior happening here at at 2. So as I approach 2 from the left and 2 from the right, you can see the vertical asymptote is also present. And then we also have a couple other things going on. And I'm going to do this just a little bit lighter. This looks like we have a vertical asymptote approaching potentially maybe a 1/2 or a -1/2 point, -0.5. Then also my graph kind of looks like it's going down here. If I draw a vertical asymptote, I'm thinking, is there a vertical asymptote right here on the left? And that is not the case. You can actually see, if I can grab it, you can see this line, the function actually starts to head back down. So that's a little bit of a kind of a deceiving line. I'm going to erase that because it's not officially a horizontal asymptote. But you can see this one actually starts to plateau out. So knowing those pieces, let's identify domain. My domain are all the possible x values that will work. Well, we know that -1 and +2 are not in my domain because of the vertical asymptotes. So my domain is going to start from the far, far left at -infinity, and it's going to approach 1, but not cross it. And then we're going to union that with the middle chunk. So here I have the boundary between -1 and 2. And then I've got the third piece of the graph that starts at 2, but it's not included 2. So soft bracket on all of those, and it's going to go towards positive infinity. All right, my range is the y values. So now I'm looking at the outputs, and I'm thinking, what outputs are present? Now we have to look at this. Notice this graph goes to -infinity, and it's going to go all the way up to at least positive 1/2 maybe. And then this part of the graph starts below 0 and it goes all the way up, which actually means my range is all real numbers. So a little bit of an interesting piece, but all outputs can be reached at some point. My horizontal asymptotes, those are as we approach the far, far left or the far, far right. Well, we can see this line. I'm going to have to make a slight guess because we don't have the function itself. I'm going to call that let's say -0.4, maybe 0.3. But the horizontal asymptote is -0.4. If you said something close to that, you'd be fine. And then we already identified the vertical asymptotes. Those are the two vertical dotted lines, and they're at -1 and x equals -1 and x equals 2. All right, next one. Wrong way. Go ahead and find the domain, range, vertical asymptotes, and horizontal asymptotes of this function, and then also find the point f of 3. Go ahead and hit pause. All right, after you tried it, let's come back, and I'm looking at my domain. Domain is all possible x values. Now, this one looks a little bit tricky. Officially, think of it here. You don't see any part of the graph except for this notation says there's an arrow. It's going to keep on going, 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 going. So even if I'm really far to the left, I'll have an output that's super high. So negative infinity all the way up to 3 is going to be the first part of this graph. And then I actually have 3 is included. And then I've got all other points. So I might actually say, you know what, if I do this and I say 3 is included, I kind of want to say, you know what, every single output or input is possible on this piece. What I should have done is added continuity, because that shows us the difference piece here. Maybe I'll throw that in. So domain is all real numbers. Even though there's a break in the graph, notice how 3 has a point. So all x values can be represented on this function. And we want to look at my range. Well, what about the range? Notice how we go forever down to the left, and we're going to go up until we hit 0. So those are my outputs. I'm going to start at negative infinity, because that's where this graph is going, is it's continually going down. And then it's going to go up to 0, but notice it includes 0, so I'll have a hard bracket there. And then the next output we would reach is the open circle at 2. So we're going to union that with an open circle at 2, and then the graph goes all the way up to positive infinity. I'm going to throw in continuity on this problem. I didn't ask you to do that, but let's look at continuity. Well, where is it continuous? The function is continuous on the x value from negative infinity all the way until we hit the open circle at 3. And then at 3, there's the jump discontinuity. And there's actually a removable discontinuity as well. They took this point and removed it, and then kind of have a jump discontinuity combined together. But then we're continuous from 3 on to infinity. So we'll union that with 3 on to infinity. And there's the continuous statement for this one. Notice we do not approach a specific output as we go to the far, far left or the far, far right. So for the vertical or horizontal asymptotes, there are none. And vertical asymptotes, we do not have any undefined functions going to positive or negative infinity. So there are no vertical asymptotes either. And then this point says, what is the point f of 3? Well, the point at f of 3 is what is the output when x is 3? And you're looking for the filled in dot. It's right there at negative 5. Okay, for this one, right, here's the piecewise function. We're looking at, can you just evaluate the piecewise function at the 3 separate pieces? So go ahead and hit pause, try this problem. All right, let's look at 7. Remember, these are your inputs. These are your x values. So f of 7, what happens when 7 goes into the function for f? Well, we have to figure out which branch is going to be represented. And notice, this is the spot where x is greater than 6. So 7 is greater than 6. And here is the function. It says 4. Well, that's a constant. So it doesn't matter. Any number greater than 6 going in will always have an output of 4. The next one, what about f of 0? All right, where is 0 on this graph? Well, 0 is less than 1. So now we're looking at the top equation, and I need to plug 0 in as a function. So 0 is going to go in as the input, and then we just have to evaluate. So parentheses first. We're going to square. Notice how the negative is on the outside of the parentheses. So f of 0 is equal to negative 5. And the last one, let's find f of 4. So 4 is between the inputs of 1 and 6. So we would use the middle equation, which is x minus 7. And we're going to basically just plug in 4 into the function. 4 minus 7 is equal to negative 3. All right, graphing. This is the fun one. Now we have to graph the function. We want to graph the piecewise equation. So go ahead and hit pause, graph these functions, and we'll come back. Okay, so as x is less than or equal to 0, the output is always 3. That's just a horizontal line at 3 units. So I'm going to go ahead and put a closed circle right here, because when x is 0, f is equal to 3, and then every point to the left of that is equal to 3. There's the first piece of my graph. The second piece then is for anything greater than 5. Notice there's a large gap. There's items missing. That is completely fine. Those inputs are not part of this domain. So now I have to figure out, well, what does this graph look like? You have a couple options. What if I just plug in 5? I know it's going to be an open circle, but if I plug in 5, I get negative 5 plus 4, which is equal to negative 1. So here's 1, 2, 3, 4, 5. When x is equal to 5, it's going to have an output of negative 1, but there's going to be an open circle there. And since you know that that's a point, this is linear. It has a slope of negative 1. You could continue this pattern and go down 1 over 1. Down 1 over 1, down 1 over 1, and you could finish the graph using slope all the way to the end. If you didn't like that, pick other numbers that are larger than 5. So let's pick 6. Now notice when 6 goes in here, it becomes a negative 6. And we get negative 2, which is go over 6 down 2. And you can see that point was also the same thing with the slope. However you get it, there's your graph. Now, you should be thinking, I can easily find domain and range. I could identify a horizontal asymptote. And I could talk about continuity as well. All those are good questions to think of, but we're not going to ask those. Okay, we're going to really quick talk about this Delta Math assignment. You don't have to write this part. I just want to give you some feedback from the assignment from the other day. So you were asked to, you could watch the help video. That definitely would be helpful. I'm going to jump ahead a couple problems just so we don't do ones that you had to do. And let's look at a problem like this. So graph the piecewise function given below. There's two pieces, and I have my domains. So let's graph the first part, negative x. That's a linear function that has a y-intercept of 0 and a negative slope. So I'm going to click on this piece right here to move it. If I wanted to move it, I could move this blue dot around, but it's got a y-intercept of 0, and its slope is down 1 over 1. So there's a negative slope. And I'm done with that piece. Now I have to set the domain. And notice your circles. I've got a greater than, or excuse me, less than or equal to circle right here at negative 4. So I'm going to bring in this domain until I get to negative 4. And then I want it to be a closed circle, which it is. And then this side says x is less than 3. So my function has to be less than x equals 3. I'm going to bring it to 3. And then I'm going to make it an open circle because of the no underline there. This is saying x is less than 3. So this is the piece of this function from negative 4 to 3. Open circle, or closed circle to open circle. Now I have to graph the next part. And this is the thought. This is not easy, but you have x minus 4 squared. Well, that's a parabola. And if it was just x squared, if the minus 4 was there, it would look like this. But then we have to think minus 4 is a transformation. What does that do? It transforms by shifting the graph opposite of what you think, 4 units to the right. 1, 2, 3, 4. And then notice my domain. So I'm done with the shift. Now I have to set the domain, and it's going to go to positive 3. So I'm going to start at 3. Notice that's a less than or equal to symbol, so it's going to be a closed circle. So I'm happy with that. And then I'm going to go to 6. Well, 6 puts my function here. When x is 6, there's my output. And that has to be an open circle. So I'm going to click on that to make it open. And that's what my piecewise graph should look like. I'll hit submit. Yay, I got it right. Okay, so hopefully that gave you a little bit of feedback. Here's what we got. Your homework tonight. Submit a photo of your notes that you took today from watching this video, and then complete any of your missing work and submit that to the correct spot. Couple reminders. We have a test next week, Friday. Please note that there are no retakes for this test, and all the Chapter 1 work is due by noon on Friday, no exceptions. Okay, so if you have any missing work, that has to be done by next Friday. This should be the Friday of the test. Okay. All right. Adios. Enjoy your asynchronous day. I'll see you on Monday.